Hello, good morning. This is Naz from NV Network Lessons. Hope everyone's doing okay. My today's topic of discussion is physics. This is going to be lesson number 1. I'm going to introduce you with physics today. Physics has been one of my favorite subjects during my college years, and I still have a passion for it, and I want to grow more in physics with you guys. So, when you talk about physics, the first scientist who comes to mind is Newton. Everybody knows who Newton is. So Newton is one of the scientists who built foundation of physics. Everybody has heard that Newton saw an apple dropping from a tree and thought about it and said, why is it coming down? Why is it not going up? I don't know if that's true or not, but there are a lot of people, even books talk about this. So have you ever thought about that, when an apple falls from a tree or a ball falls from a high-rise building, why is it coming down? What speed it is coming down? Why is it not going up? And things like that. As a matter of fact, Newton is the one who came up with calculus, okay? He's the one who presented physics in form of calculus. So we can say that Newton was the inventor of calculus. Now, in this particular section, what I'm going to do is I'm going to talk about calculus in terms of algebra. Talk about physics in terms of algebra. So if you want to learn physics, you don't need to be a rocket scientist, okay? All you need to know is know the basic algebra, and then I'm going to try to build some foundation into that, and hopefully we'll go somewhere. Another thing, what I ask is that, is everything has been discovered in physics? Is everything out there is hunky-dory and we can go and say this is it, XYZ, whatever? Is it everything definitive? The answer to that is no. Yes, we have science. Science has progressed a lot over the years, but we still don't have answers. And we're going to talk about that also during my course. So stick with me. In Physics 1, what we're going to discuss is we're going to try to drill down into what is motion, what is force, what is energy, okay? So this is going to be part of my discussion. We'll discuss this a lot, okay? So if you love physics, this is the place for you. So let me ask you this. When it comes to motion, let's say you have a ball, right? And you have a track, flat track, and you push the ball with certain amount of force. The ball rolls, and eventually stops. Why? Why did it stop? That's Newton's first law of motion, and we're going to talk about that. Well, obviously, when you roll the ball on a track, if there is zero friction, zero air friction, zero any sort of friction, yes, then ball will keep on rolling forever. But that's not the case. There is friction of the wood track. There is air which is resisting the movement of the ball. So that's why it eventually stops. And we're going to explore all of that. So, okay. So let's see. We talk about let's talk about one-dimensional motion, okay? One-dimensional motion of an object, okay? This is basically the same thing which I just gave you. So you have a track right here, straight track, right? And I roll the ball, okay? That's one-dimensional motion. Easy peasy. Now let's look at the two-dimensional motion. What is a two-dimensional motion? Two-dimensional motion. Now in two-dimensional motion, if you take the same ball and you throw it up in the air like that, or you a pitcher in baseball, throws a ball, right? That ball has a projectile motion. It's not going straight like this case in one dimension. It's going to go like this. So that is two-dimensional. So you have something like this. Motion is something like this. All right. So that is two-dimensional. So in motion, then we have a concept of velocity. All right. What is velocity? A lot of students ask me, what is velocity? Well, velocity is speed, right? So now it's basically how many meters per second you are going, how many miles per second you are going, how many kilometers per second you are traveling, and so forth. In my times, now the terminology might have changed. In my time, what we used to say was S is equal to distance, okay? Now I think they just call it just D, all right? So what we can do is, as you know, velocity is, what did I just say? Miles per second. So velocity is distance over time. All right, no rocket science to that. All right, so if that's the case, can I say distance? Just do some algebra. Is equal to velocity multiplied by time? Yes. So the formula, which I remember still from years ago, S is equal to Vt. All right, distance is equal to velocity into time. All right, so let's say you have, when you have a projectile motion, the motion which I just showed you right here. So let me just go ahead and see if I can erase that and show you something. So let's say you have a axis like this, right? And you throw the ball kind of like this. What am I interested in? What I am interested in is that how high the ball has gone, right? How far the ball is going, and how much time did it take for the ball to be in the air. These are the three things I'm interested in. Now, further you can do is, in case of projectile motion, you can say you need to find the force going this way, all right? And then you need to find the force this way, all right? When you toss something up like that, you have a horizontal force also, you have a vertical force also, which is basically combined, and then you get a projectile motion. And then we can say angle right here is theta, or whatever angle, So this is kind of this is something which we will drill into. So I think I'm going to leave it right here. I don't want to overwhelm you guys. Just basic stuff right now. But gradually, if you love physics, stick with me, because, I want to teach you guys, and beyond what I know, because I'm learning myself. I study books also. I learn everything every day. So whatever I can share with you guys, I will share. All I ask you is to, basically share this and go ahead and give me a like. Thank you so much.